Welcome to this Fabric Data Days edition, where we explore how Microsoft Fabric connects seamlessly with LMS to unlock the power of learning data analytics. Moodle's data architecture is incredibly rich with hundreds of interrelated tables covering users, courses, enrollments, activities, and grades. This complexity enables powerful learning management but also poses a challenge for analytics. For effective analytics, we focus on three core tables: users, courses, and enrollments. Together, these form the foundation for any learning analytics model. Let's take a quick look at internal database structure, showcasing the depth and relational connectivity that powers it as a full-scale LMS platform. It operates using MySQL and features over 400 plus interconnected tables that manage everything from users and courses to activities, logs, enrollments, and grades. If we open the course table, you can see its core attributes: category, visibility, metadata, and timestamps, along with several related tables that extend its configurations and activity. Similarly, if we browse the user table, we can see all user attributes, authentication details, profile fields, and several linked tables that track enrollments, roles, permissions, and activity logs. The primary challenge is to combine and contextualize these tables for meaningful analysis. Microsoft Fabric simplifies this process by enabling us to extract, model, and connect the data efficiently through the REST API. So why should we connect LMS with Microsoft Fabric? Let us explore the challenge and the solution. Organizations often struggle to unlock LMS-rich data for advanced analytics, reporting, and data-driven decision-making. Microsoft Fabric addresses this by offering a unified analytics platform that connects directly to REST APIs, enabling seamless data extraction, transformation, and visualization at an enterprise scale. Let us begin by setting up Moodle's REST API access, the gateway that allows Fabric to communicate securely with Moodle. To enable programmatic access, we first configure a custom web service under Site Admin, Server, Web Services, External Services. I have already provisioned a service named My Service and bound the required Moodle REST functions to it. We then navigate to Manage Tokens to generate an authentication token mapped to this service. This token becomes the system identity that Fabric uses to execute API calls, supporting fully automated, unattended data extraction. As a final step, we validate that the token is assigned the correct capability set, particularly read permissions on users, courses, and enrollments, ensuring secure and least privileged access for our data pipeline. So once API access is ready, we can begin extracting data. Let's see how Python helps us connect and pull data from LMS. We will use Python's request library to interact with LMS REST endpoints and to process the responses. Each API call follows a simple structure: your URL, the authentication token, and the function name. We will use three key API functions as shown in the screen. Here's a quick demo on fetching courses and enrollments directly from LMS REST API. and loading them into data frames. This code demonstrates how easy it is to extract clean, structured JSON data from LMS and convert it into data frames for analysis. After extraction, we preserve all datasets, users, courses, and enrollments as CSVs in Fabric's raw data zone. The raw zone ensures data integrity, supports auditing, and allows reloads without repeated API calls, creating a strong foundation for further transformation. Here's how the CSVs are stored and organized in Fabric's workspace. As data volumes increase, we use Apache Spark in Fabric for faster distributed processing. Here's how we load CSV files into Spark data frames for efficient large-scale data handling. Next, we optimize storage using Parquet and Delta formats, balancing performance and reliability. Parquet offers fast reading speeds and compression, while Delta supports ACID transactions and allows direct connectivity to Power BI. Here's how data frames are as Parquet and Delta tables inside Fabric's Lakehouse. Now that our data model is ready, let's automate the entire process using Fabric data pipelines. We schedule our pipeline to run regularly, daily, weekly, or on demand, providing you with up-to-date data for informed decision making. Integrated monitoring tracks each pipeline runs, providing error alerts and insights on load times. Finally, we link a semantic model refresh to keep Power BI reports always up to date after every successful data load. Here's how the automated pipeline runs from extraction to semantic model refresh.